got liquid water flowing isothermally at 20 degrees Celsius through a 1 inlet, 1 exit duct operating at steady state. The duct's inlet and exit diameters are going to be 0.02 and 0.04. And at the inlet, our velocity is 40 meters per second and the pressure is at 1 bar. At the exit, we want to find mass flow rate in kilograms per second, and we want velocity in meters per second. Now, first, notice that word right there, isothermally. What does that tell us? It tells us that the temperature is going to stay constant. Then we've got steady state. That will help us along with our mass flow rates. And then that's about the only keywords we really need to pay attention to. Now let's write down what we've got. So our temperature is going to be 20 degrees Celsius. Now we can't just leave everything in Celsius. We need to convert that over. So let's have 293.15 Kelvin. So now we have that. And then our diameters. We've got the initial diameter. That's going to be at 0.2. And then the exit diameter is 0.04. Now our velocity is going to be 40 meters per second initially, and the pressure at that inlet was 1 bar. So now we've got that. And what we want to do is we want to find mass flow rate and velocity at the exit. So we want ME dot, and then we also want VE. So those are the things that we are looking for. Now, first thing, if we're looking for a mass flow rate, let's look at our equation we've got. We know M dot for the exit has to equal the density of the water at the exit, the area of the exit, and the velocity of the exit. So you got to multiply all three of these together. Another way of writing this would be AEVE over specific volume at the exit. And we're going to switch to this form because we can look this up in the table. This VE. Density, not so much. So now at the exit, remember our temperature is not changing. So at this exit, we are going to approximate that value using the saturated water table. All right, because if you look at 20 degrees Celsius and just to get an estimate, you look up 1 bar, you'll find you got compressed liquid. So we're just going to do an estimate, and we're going to say that VE is approximately equal to the saturated liquid value for a specific volume at a temperature of 20 degrees Celsius. So if you look that up in the table, you'll find that the specific volume at the exit is approximately 1.0018 over 1,000. And that's cubic meter per kilogram. So go ahead and divide these. We'll get 0.0010018 cubic meters per kilogram. Now we've got our specific volume at the exit, an approximation at least. So we've got that done, and we got to know our area, which we can find area. What about our velocity? We don't have that yet, right? We're looking for that. So let's figure out what else we could do. We know this is steady state, so we know that, let's just say it looks like this. If we're coming in here, coming out here, we've got an M1 dot or an MI dot, and then we've got this ME dot. If it's steady state, what do we know about those two things? We know that they are the same value. So MI dot's got to equal ME dot, since they are steady state. Now with that, we could do this equation for the inlet and the exit, set them equal to each other. That'll be our next step. So we'll have AI VI over little vi. That's going to equal AE VE over little VE. Then we just need to fill in the values and see what we are left with. Okay. So now, for our area at the inlet, our diameter is 0.02. So we're going to have pi times the 0.02 meters, and then work that over 2, square that, multiply by 40 meters per second, and then put that over your specific volume. We're going to assume it's the same thing that we had here, because again, if you look up 20 degrees Celsius at a pressure of 1 bar, that's really compressed liquid. My compressed liquid tables don't go down that far, so we're to that pressure, so we're going to just use an estimate. Alright, so we're going to have the 1.0018 over 1,000 cubic meters per kilogram, and then we're going to set it equal to the conditions at the exit. So we'll have pi times 0.04 meters over 2, square that. Then you got velocity of the exit, which we don't know yet, and then we're going to divide that by specific volume. So there you go. Alright, so now if we go ahead and solve these equations here, we're going to get the exit velocity is going to be 5 meters per second. So now we have that. And then if we find the mass flow rate, we're just going to use this equation here. Alright, so let's call it equation 1. So from 1, we're going to have pi times 0.04 over 2, square that, that's meters by the way. Multiply that by the velocity at the exit, so 5 meters per second, and then put that over 1.0018 over 1,000. That's cubic meters per kilogram, and then go ahead and solve. You get ME dot is 6.272 kilograms per second.